The sum of the first 7 terms of a geometric series is 7, and the sum of the next 7 terms is 896. Find the common ratio, so find or. So the first 7 terms, the sum of the first 7 terms is 7. So I'm going to let S7 equal to the formula. This is my sum of series formula for geometric series, which is Sn equals A times 1 minus r to the power of n divided by 1 minus r. So the sum of the first 7 terms is 7. So I have S7 equals A times 1 minus r to the power of 7, so swapping that n for 7, divided by 1 minus r. And that is all equal to 7. Then I'm told the sum of the next 7 terms is 896. So 7 plus 896 is going to give me 903. So the sum of the first 14 terms will be 903. Because if the sum of the first 7 is 7, and the sum of the next 7 is 896, then 7 plus 7 makes 14, and 7 plus 896 makes 903. So S14 is equal to 903. And we use our formula again, swapping the n for 14. So once we have our two equations set up, we just have to solve for r. So we're going to let a times 1 minus r to the power 7 over 1 minus r equal to 7, and divide both of those by our other formula that we've created over here. So we have a times 1 minus 14 divided by 1 minus r equal to 903. And then all we have to do is cross multiply. And it doesn't matter which is on the top and which is on the bottom, so this could have gone on the bottom either. It doesn't make any difference. So we're going to solve for r. Before we cross multiply though, we can start to cancel some things out. So we can cancel out the a top and bottom. We can cancel out the 1 minus r top and bottom. So we have 1 minus r to the power 7 multiplied by 903. And we have 1 minus r to the power 14 multiplied by 7. So then we multiply across. 7 by 1 is 7. 7 by minus r to the power 14 is minus 7 r to the power 14. 903 by 1 is 903. 903 by minus r to the power 7 is minus 903 r to the power 7. Then we bring everything over to one side. So the minus 903 or 7 becomes positive 903 or 7. And then 7 minus 903 is going to be minus 896. And that's equal to 0. Then we divide across by minus 7. So we get r to the power 14. Then 903 divided by minus 7 is minus 129 r to the power 7. And then minus 896 divided by minus 7 is going to be plus 128. So this is all equal to 0. So then I'm going to break down r to the power 14 to be r to the power 7 raised to the power 2. So we're using our laws of indices here, where if we raise a power to a higher power, we multiply the powers, but we're working it backwards. So the factors of 14 are going to be 7 times 2. So I want the 7 inside the bracket and I want the 2 outside the bracket. Because what I can do is pretend that the r to the power 7 is just an x. So this is basically like having x squared minus 129x plus 128 is equal to 0. So we let the r to the power 7 be an x. So if that was x squared minus 129x plus 128 equals 0, we would factorize, opening up two sets of brackets. We would have an x in the front of each bracket. We would get the factors of 128 that add together to give minus 129. So instead of an x in the front of each bracket, we're going to have r to the power of 7 in the front of each bracket. The factors of 128 that add together to give minus 129 are going to be minus 128 and minus 1. We can check does this work by multiplying out the brackets. R to the power 7 by R to the power 7 is R to the power 14. R to the power 7 by minus 1 is minus R to the power 7. Minus 128 by R to the power 7 is minus 128 R to the power 7. Put them together to get minus 129 R to the power 7. And minus 128 by minus 1 is plus 28. So our factors work. So now we just have to solve. And we're going to let R to the power 7 minus 128 equal 0. So R to the power 7 will equal positive 128. So R is going to be the 7th root of 128. So R is going to be 2. We don't need to bother with R to the power 7 minus 1 equals 0 because that would end up giving us R is equal to 1. But the common ratio cannot be 1. Because if you're multiplying every term by 1, you would just end up with the same term each time. So the ratio cannot be 7. The ratio must be 2.